Okay, I'm going to talk about the easy things to get. Certainly the Y-intercept, you can get that by inspection. The Y-intercept that occurs at when Y is 16 and X is 0. This is called a relative maximum here. This over here, there's a relative minimum. This is a root. This is a root. There's also a point of inflection. And again, the point of inflection, looking at it, it might be hard to detect, but I do see concavity. And what I mean by that, it's a cubic polynomial. I'm seeing something like this over here. So I'm definitely seeing concave down and a concave up. It might be hard to detect exactly where that occurs, by the way. What I want to do is go to the whiteboard and see if I can do it, all right? So it's good to have a good picture, by the way, but now I'm going to whiteboard, the picture disappears, and the point of that is you're usually in the dark and you want to try to put the lights on, so to speak. We started with the lights on, now we're going to turn the lights off. And I'm going to push this back up, and I'll write it down. And it's number 3, right? So let me write down number 3 for you. Got to get to the that section of the notes. So f of 3, I'm sorry, not f of x. This is problem number 3, is x cubed minus 12x plus 16. All right, kind of looking at it, and I'm going to go back to something we've been talking about for a very, very long time, and that's the rational root theorem. All right, and I'm going to say, looking at it, the rational roots, plus or minus, like the factors of 16, by the way, 1, 2, 4. You get the idea. But I'm hoping it's going to be easy. 1's out of the question. There's no way I'm going to try 1 or minus 1. But I'm going to try 2. Let me put this down, 2. So what's f of 2? Looks like a good candidate for a possible root. It's in the list. That would be 8 minus 24 plus 16. And what do you get there? 0. So what do I know now? I know f of x is equal to x minus 2 times some quadratic. And let's put this down. So it's going to be x squared. Now, why x squared? Because I have an x cubed. Plus bx. I don't know what that is. I do know what the last term is, though, and it has to be minus 8. Let me erase that. Put a plus on, but I meant to say minus 8. Now, why minus 8? The product's got to be 16. Now, what I'm going to do is I'm going to equate coefficients. I'm not going to do long division, by the way. So what do I get? I know there's no square term. So minus 2x squared plus bx squared must be nothing. So what would b have to be? B would have to be minus 2. Now granted, I'm not beyond making mistakes, and I want to check it. So one says, how would you check that? I'd multiply it out. Let me erase this, and I'd go for the multiplication now. And what do you get there? X cubed minus 2x squared minus 8x minus, wait a second, did I say minus 2x squared? I think I made a mistake, and I'm glad I checked it. I'm going to put plus 2x down. Let me check it. And I'm glad I'm really checking, Otherwise, I would have been in a wild goose chase. Let's check it again. X cubed plus 2x squared minus 8x minus 2x squared minus 4x plus 16. Well, if you add that together, what do you get? X cubed minus 12x plus 16. Exactly what we expected to see. I'm going to erase this over here. And then I'm going to go the next thing on the analysis and try to figure out that. And it looks like it's factorable. Now let's put this down. It looks like 2 and 4 plus 4 minus 2. So I'm seeing a repeated root. And the repeated root is actually the 2. So I can write my roots down now. Put this over here. The roots are going to be, well, one occurs at the number 2, and it's repeated, and the other one occurs at -4. I just want to get a rough idea what it looks like. So what I'm going to do, I'm going to do sign analysis on the function. What I know about this thing, where it's not 0, it's always positive. So basically what I'm doing is looking at, let me write this down for you. This is going to be at -4 and at 2. The analysis is pretty simple, right? So let's take a look at that. It's going to be positive here. It's going to be positive here. And it's going to be negative over here. Now what does that mean? Something like this. It's negative here. And then it's positive. It's got a y-intercept around 16. Maybe something like this. And then it's positive over there. All right, rough picture. That's all it is. Very rough. All right, what are the roots? The roots are -4, 2, and 2. There's 3 roots. Okay, I want to continue to go through the problem now, and someone says, why is that? Just to see what happens. All right, let's look at the derivative. I want to refine my picture, so to speak. What do you get there? 3x squared minus 12. I'm going to factor that. I'm going to factor a 3 out. And what do you get? X squared minus 4. This factors to 3, x plus 2, x minus 2. So I'm going to do my analysis on that derivative now. Very simple analysis. And I see 2 different places where this would be changing signs. So if you go after 2, like pick a number like 10, it's positive. Right, that means the function's going up. Between -2 and 2, I pick 0, it'd be negative. Function's going down. If I go below -2, it's going to be positive. All right. So at -2, I get a maximum. I should say relative maximum. This is the y-intercept, by the way, which is 0, 16. At 2, I get a relative minimum. All right, not bad. Relative minimum over there. Everything's coming into play. Let's keep going. Let's get that second derivative. 6x. So there's a point of inflection now at 0. After the 0, it's positive. This is the second derivative, by the way. Concave up. Below the 0, it's negative. Concave down. So not only is this a y-intercept, it's also a point of inflection. And again, we did more than expected, but we should be doing more than expected. We should try to build up on a skill set that we've seen before. Thank you.